Hello and welcome everyone. Thank you for joining us today for the Balancing Engineering Autonomy and Agility with Cloud Costs Through Resource Governance webinar. That is a mouthful. My name is Daniela and I'll be the moderator for today's session. I'm excited to introduce Andrew Hillier, CTO and co-founder here at Dentify. Hello, Andrew.
Hello, hello.
And he will lead today's session and take us through a new approach to resource and cost optimization, as well as the demo of the capabilities in our UI.
First of all, who we are SaaS Analytics, and we're basically analytics that align supply and demand. It looks at the workloads, it looks at the cloud offerings, the container configurations, and constantly aligns them across the major cloud providers and the Kubernetes running in the major cloud providers. So all the Kubernetes variants that are up there. And I'm not talking about containers today. I'll be focusing on cloud. I'll be talking about all of them a bit, but picking on Azure mostly because some cool stuff we're doing. And again, I'll do a bit of a demo, not in a comprehensive demo. So if anybody would like to see more, we can follow up after the fact. Let's start with kind of our view on cost optimization. And we view it as a bit of an iceberg where, I mean, if you look at most organizations today, obviously been a big focus on getting discounts and the bill and understanding the bill and, really optimizing the price you pay. And I think a lot of organizations have done a pretty good job of that. It's rare to find someone now without discounts and some kind of plan in place. And our view is that the big frontier now in cloud cost is the resources themselves, not the price, but the quantity, the amount you're paying for. It's really standard price times quantity. What you're paying is the unit cost times how many you have. I'm sure you've negotiated all with cloud providers to get the best P. And now what we focus on is the Q, the bottom of this iceberg, where we feel the lion's share of the go forward opportunity is. This is a bit challenging to do because, again, with the emergence of the cost problem, there's been a lot of tools, a lot of focus on the bill and cross-charging and quotas and kind of, some very fundamental ways of making sure you control costs or at least give visibility. But when it comes to resources, it kind of starts to get into the domain of the engineers, the app owners, where they're deploying things, and to optimize what's deployed becomes the name of the game, which is kind of a bit outside the financial realm. It's more in the technical realm. And that's where we see this big gap. Are the resources aligned with what the workloads are doing, both when you deploy and, a month later, a year later? And that's what we focus on is really, and I'll talk a lot about cloud instance selection today. How do I choose the right offering from my provider? The right instance family, the right CPUs, are my skill groups elastic, containers, things like that. I won't talk much about that today. We have other webcasts that cover that, but really about instance selection. And the challenge here, I think, is that from the tools that are used at the top of this diagram aren't necessarily very good at this. Some of them might have some basic capabilities there, but what we found, it takes a lot of rigor and precision to do this correctly so an engineer can actually do it. And I think that's borne out by, the FinOps Foundation in their yearly survey, perennially at the top of the list is empowering engineers to take action. You can't give the engineers bad recommendations or very basic or, hey, try this, it might work. It has to be very precise. And I'm going to extend that today. Not only has it be precise, but you also want to give the engineer a bit of freedom to do what they want to do. You don't want to just kind of say, do this or not. In fact, that first line used to be called getting engineers to take action. And I think they reworded it because they realized that's not really what you're doing here. You're not forcing stuff down engineers' throats. You're empowering them to make the decisions that they make because they have lots of reasons why they do what they do. And what you need to do is empower them to do that. So even the very wording of this survey has changed to kind of reflect this mantra, which I'm going to get into quite a bit today. Now, part of the reason this is very difficult is because if you look at a provider catalog and what they offer, it's extremely complicated. And I mentioned I'm going to talk about Azure quite a bit. Let's pick on a standard DS4 V2. Let's say I'm a workload running on a DS4 V2. It's an 8 by 28 for whatever reason, 28. And but that's very old. It's a V2. What can I do with this? It may not be the right size. Certainly, it's too old. But if I want to figure out what to do with it, it becomes very complicated. There's a DS4, but that's older. I don't want to go backwards. That's really a good idea. A DS4 V3 would seem like the right way to go, but that actually doesn't exist. What does exist is a D4S V3, and this starts to get a bit comical. It's the same letters in a different order. Is that the right one? It's got a 4 in it. Nope, it's only half the size. The D8S V3 is actually the one that's kind of the size that I'm currently on. So that seems like a good one. And yep, that actually indeed would work, but it's still only a V3. It's still quite old. So what about the V4? Can I go newer? Nope. Sorry, doesn't have a disk anymore. The disk is on the D8DS V4, so that one works. And the D8DS V5 is the lucky winner here. That's the one that's the progression of where you are right now. But this is not at all obvious. This is just one workload. I mean, imagine trying to figure this out for thousands. Still may not be the right answer because we've seen this case in customers and we have policies to figure all this stuff out. And we've seen cases where the new ones only have half the disk and network capacity adapter capacity, and that has bitten them. If you move to the newer one, you can't have all your disks anymore. So these are real constraints. If you do this wrong, then things break. So when things break, engineers, their job mainly is to make sure things don't break. So they're not going to do anything if you give them a bad answer. If you give them any answer other than the right one on this diagram, and still it might not be the right answer because there's burstable and memory optimized and compute optimized. Those might be the better option for the workload you're on. And in Azure alone, there's over 600, as of last year, there's over 600 offerings. I'll show this in some detail. And there's probably the perfect one for your workload, and you're probably never going to find it without the right analytics. So that's exactly what we do. I'm just going to kind of go through how we work before I get to the resource governance topic. We start by taking all the raw data, agent lists, just from the different provider APIs, and we have different algorithms to the machine learning on it. One of the main ones and one of the coolest ones is what we call combined type, where it goes back through history and builds out a profile of what every workload does by hour. So we kind of build this operational profile, which is extremely useful for understanding the characteristics of an application. We understand the peaks, what we call sustained activity, the shape of this, the size of this. All of this stuff is very important to figure out where, what I should run something on. So kind of step one is characterizing the workload, and you'll see these curves a bit more later. Then we analyze it against the entire provider catalog, and this is just a small section of the Azure catalog. And again, the catalog is very, very complex and very sophisticated. There's all kinds of different options. There's entry level, there's more advanced offerings, GPU, HPC, different types of optimized offerings. So we figure that out by looking at the characteristics of the workload and very detailed policy. I won't get into the details. I'll show you visually what this looks like, but things like how busy do I want to be? Obviously, I need enough disks and HBAs, and am I using premium storage? All of these things go into saying, okay, we can score this workload against the entire provider catalog and figure out where it can and can't go. And then based on cost, come up with the best possible answer. And in this case, as in the previous example, the DS4 goes on to a D8 DSV5. So we will figure this out automatically. We do it all the time, and we tell you what the best answer is. We also tell you why you shouldn't do the ones that are, for example, scoring poorly. Like, why not this D8S? Well, the rule engine's picking up that it doesn't have a local disk, and even looks at whether you're using the local disk. So you're using a local disk. This one doesn't have one. That's not a good option for you. So the devil's in the detail as far as getting the right answer, and it's also very important to communicate why some things are not the right answer, because there's not just one right answer, as I'll get to in a minute. But the name of the game is to come up with answers that engineers can actually implement. We constantly do this for thousands of instances. It's constantly running here, and I'll pull this UI up in a few minutes. But you can see the different types of recommendations. Make something smaller, make it a different family, make it bigger, make it newer, and all the supporting evidence you see at the bottom here. This is what the workload is doing right now. It's a little bit too busy for us, the blue curve. If we do what we're saying, it'll look like the green curve. It's going to be better, or it's going to be cheaper, or whatever the case is. So very detailed, transparent analytics, all available through APIs and also through reporting. So when we do the analytics, we not only give the right answer, we say why it's the right answer. And we do that, for example, in what we call an app owner report, saying, hey, here's the policy that we're using. We've looked at 95 days of data with very conservative policies. This is what you currently look like. And we're saying, if you optimize, you will look like this. You'll be great, and you'll save a ton of money. So I want to stress, this is extremely important. If you ask an engineer, and if you recommend, say, hey, you should do this, without supporting evidence, they probably shouldn't do it. They need the evidence. They need the rationale, as one of our customers puts it, to act. And if you lay it out this way, then, okay, now they got it. They have all the details, and they're much, much more likely to act on this recommendation because they can trust it. And again, from an engineering discipline perspective, you need to have this much detail. So we're very, very good at providing this level of detail. Now, just to wrap up this section, and then I'll get to the main course here. So when we have that, that really good answer, you have to start with an answer that's doable and correct. Then there's all kinds of ways it can happen. So we have an ITSM module that will open a change ticket to get to the app teams, and then that app owner report is an attachment to that change ticket. They have everything they need to understand and to either approve or deny or defer or whatever they're going to do, or to act and actually optimize. And very, very much an ITSM driven approach to doing this. And that's kind of a common starting point. We also have a Terraform module. So if you want to be a little more sophisticated, you can put a line of code in your Terraform. It hits our APIs. When the answer is approved, a new answer shows up in the Terraform. And then through the magic of infrastructure as code, it will automatically automate the update in the field. So it's very elegant. You change the Terraform, and then what's running changes, all under ITSM governance and control. So this is a very, very nice closed loop optimization mechanism. That's optimization, and we call that optimization as code. And so let's kind of shift the main topic today about resource governance. So We were looking at this diagram, I'll tell a bit of the backstory. We were talking with, partners of ours, and I showed Terraform here, so Hashi, Microsoft. And, one thing we were pondering is like, well, is there a different way to do this? So now we're still going to hit all the app teams, the engineers, and ask them to do something, or at the very least, ask them to add a line of code to their Terraform. Are there other ways? For example, can we just talk to the infrastructure, and if it's approved, just change it? And we call that a mutator. Kind of like if you're familiar with containers, what HPA lets you do. It'll just change it. Like they've already agreed to doing it, so we don't need to make them go and do all the stuff. Let's just make it happen. So that's one kind of topic that we get into. I'll circle back on that one in a minute. And the other bigger one was, well, can we leverage rule engines that are out there? For example, Hashi has something called Sentinel. It's a rule engine that says when I deploy, I need to meet these requirements. Maybe I need to make sure there's a password on my VM, or I need to make sure I don't open certain ports. It's a rule engine that lets you kind of make sure that what's going out is correct or compliant or under proper governance. And so we said, well, can we talk to that and implement what we do through the rule engines? So that's kind of more of a governance approach. Instead of asking you to do something, we're going to stop you from doing something you shouldn't do, if that makes sense. Instead of giving engineers, and say, hey, can you make all these changes? And they're busy. Can we just catch it in the stack and say, look, you got something that's not quite right? More of a guardrails approach. I'll show that in a second. And maybe there's not just one right answer here. Instead of us saying this is the perfect right instance, no, we'll give you a bit of freedom. You can do whatever you want within reason. We're just going to put some guardrails on what you're doing based on the analytics. So this was kind of the origin of this thought, where if we kind of work in the stack, in the policy engines, we can implement what we're doing as a form of governance and give the engineers a bit more freedom while still giving them the rigor that they can trust. To that, I've been talking about Hashi. It turns out when we started doing the research on this that there are rule engines in all the providers. Amazon has what's called AWS Config. Azure has Azure Policy. I'm going to talk more about that. That's a pretty powerful framework. And so we started working with that and working with Microsoft and doing some work there. And I'll show you what that looks like. Here is where I'm going to go live into the product. This is where it gets really exciting. I'm in the Densify UI. And now I'm not going to give a full soup to nuts demo here. If you're interested, we can certainly do that. I'm going to go right to this feature I'm talking about. So what you're looking at here is kind of the top level view of our optimization with, it's a demo environment, so not a huge environment, with some Amazon, some Azure, and some Google Cloud, and showing some various stats on the optimization. This is the screen, kind of one entry point into looking at just the EC2 optimization. Again, I won't spend too long explaining all the filters and views and what group by. Here you can see here we're grouped by application. At the bottom of the screen is a list of the applications with how many instances they have, how much opportunity there is, all the net stuff. But I'm just going to go right down into this mobile prod app, which has 6 systems, and get right down to the optimization, the slide I was showing earlier. So here is an app that has 6 instances, and we're generating a bunch of different recommendations. So there's what's called a modernize. You see this one, we're not making it any bigger or smaller, we're just making it newer. There's a downsize optimal family, and there's an upsize here at the bottom. I'm going to pick on this optimal family one, where we're saying that you can be smaller and on a newer instance type, a different instance type, from an M to an R. And you can see all these curves here at the bottom. I was talking about the kind of the machine learning and understanding what these things are doing. But let's just go right over to this analysis details, which is where the cool stuff is. This is a view of what I'm talking about here as far as resource governance. So here I'm looking at the commonly used instances within Amazon, how that particular workload scores against the entire offering. And in fact, I'm going to go back for a second and show the whole thing. That's actually an even bigger view, because again, it's a pretty complicated catalog. So up the left, we have the sizes that Amazon offers. And then across the bottom, we have the offerings themselves. And you see there's all kinds of weird and wonderful instance types here: memory optimized, CPU optimized, HPC, and you see the scores here. And let me just turn off this for a second and explain what we're looking at here. So this is the view of where that workload can run in Amazon if money were no object. And what I mean by that is, and I'll go into the smaller view just so we can kind of see. I'm going to go in on the kind of the commonly used view to explain this a bit better. The red across the bottom are all the ones that you won't fit on. It doesn't have enough CPU or memory or IO. I talked about those checks. The orange are the ones that it can't go on because it's technically not compatible. Either it's too old. You see these older ones here on the left, the R4s, the newer ones on the right, the older ones on the left. I've got here's a G4, so that's a GPU enabled. Same with G5. I'm not going to accidentally just put you on a GPU enabled instance if you're not using a GPU. That doesn't make much sense. These are Graviton, these other ones here. So you can see the rule engine firing, and it's giving me a view of what I can and can't do. So think of this like the guardrails. Like when I'm deploying something for this app, I can't go down to the red. I can't go so small that it won't fit. and I don't want to go into the orange because it's technically not going to work. Otherwise, I can do whatever I want. All these green ones are fair game, but they might become wildly expensive. So again, I'm not going to go out on a 48XL if I can fit on a small one. And you see here the highlights. We're currently on the M4 extra large, and the analytics are saying the best one is the R7i large, and the details are at the bottom. We're currently spending 117 a month. You could be spending 78 a month on that one. So that's a better choice. So going back to what I talked about at the beginning, coming up with the optimal answer that you can actually take, that's what this is doing right here. That's what this view is showing. We're on this one, we should be on this one. So if I wanted to go and open a ticket or send it through Terraform, that's what would happen. Now, let's talk about the paradigm shift here for a second. So that's with unlimited budget. But to do this resource governance, what we did, we introduced, well, not only this cool new visualization, but the concept of a spend tolerance. So that's fine if you are willing to overspend like crazy. What if I want to say, well, only you can only go up to 10 times too much money, which is still pretty ridiculous. But if I do that, now you can see there is only a subset of these ones are viable. They technically work, but they're too expensive. All the yellow is now the stuff that's become too expensive. What about 5 times? Okay, now fewer options and 2 times. And we'll pause here for a second. If I'm okay to spend up to double what this current one is, what the best one is, that's kind of the benchmark. It's $78 a month based on its current uptime. These 20 or so are all options. They're all good options, and you can do them. And you can even stay on the one that you're on. It's still fine in that one. So I've started to kind of build these guardrails now where, hey, engineers, you can do whatever you want as long as it's one of these 20. They're all within compliance as far as size and rules and spend. Once I go down to 50% more, now you see there's only about, I think, 8 options here, including the optimal one. And the current one you're on is no longer an option. It's not within that spend tolerance anymore. So what we've done is we've defined a guardrail. It's like a giant FinOps knob that you can turn to say, hey, I can turn up and down the spend tolerance and I get different results. I get different options for what I can do. The engineers can still do whatever they want as long as it's within the tolerance. The idea here being that you can jointly agree on these settings with the app teams and say, you know what, we're going to put in place something that makes sure we don't spend more than 20% more than what the best option is. And if I do that now, there's really only 2 options here. You can see we're down to 2. The rest of them are all too expensive. And if I go down to no tolerance, they're just one option. So rather than just focusing on this one answer, let's also dial it back a bit and say multiple right answers. That's one workload, but let me go back and show you. Top one is interesting because we're not making a different size, we're just making it much newer. If I look at the map for this one, you see now there's a lot more red. This is a much bigger workload. So probably half the catalog isn't even an option, it's just not big enough. We're on this one and it's not actually viable. It's too small. The same size multiple generations forward is big enough. That actually does give enough. So here is a case where just making it newer is going to make it a lot better. And we can visualize this and say, in this case, if I go down to 20%, there's still quite a few options because there are a lot of other options that are close to in price to that one that are also fair game. So again, the idea here being we're giving the engineers freedom to do what they want within the guardrails, and we can tune the guardrails based on policy. The big one being the FinOps policy of how much waste am I willing to put up with in my organization. And it's kind of a progressive setting that you can bring down as you mature. I'm going to show one more quick thing. I'm going to go over to Azure just because the Azure map is cool and different. I'm going to go into mobile dev, and I'm going to go and we'll start with this 117 one. This is the Azure map, it looks fairly different. It's a different shape. It's got different instance types. It's in many ways kind of more complicated in some ways and different sizes. Kind of the naming has the size stuck in it. And if I look at the entire catalog, it's a pretty complex catalog. This still isn't the entire catalog because Azure has a lot of really weird and wonderful sizes and constrained CPU sizes, and we analyze all of those. So this can get extremely complicated to figure out an Azure placement. In this case, you can see we're on a D2 V2 and we're recommending B2 AS V2, so which is actually technically quite a bit newer than that one. Azure, Microsoft, Google's a completely different beast. I'm not going to show that. Its catalog looks quite different. This is the visual that goes with resource governance and kind of the idea that I can go and put basically guardrails on what's being done in the field. So from a FinOps perspective, I can do some very technical analysis that includes cost to figure out what should and should not be deployed in the field. We've got this analytics now, and like I mentioned, I'm going to pick on Azure. Azure has this Azure policy, which is actually quite powerful. So once we have this map, and let's just assume like the spend tolerance is turned off, and I have all these different options for what a given workload can run on, we built a resource governance API that lets us pull that information and put it into things like Azure policy. So basically that, you can think of it as that map becoming embedded in the policy engine in the cloud stack. We run all the permutations, all the different options, and understand what works and what doesn't work based on all that complicated logic I started the webcast with. And then that turns into actual policy in Azure policy. So there's policy model and parameters that you go in to allow Azure policy to understand, hey, this is what you can do and you can't do. So if I go to deploy a D8SV4, which you remember from the start doesn't have a disk, this picks that up and says, whoa, you know, don't do that. You're using a disk. This one doesn't have a disk. The APIs and get all the details if you want to as to why. So now all this analytics we're doing is just embedded in the stack. In this case, in Azure, when you deploy, it doesn't matter how you deploy, it'll pick it up. Could be manual, could be Terraform. It'll say, whoa, the analytics say that you shouldn't do that. It can also say, that's not big enough. That doesn't have enough memory or IO characteristics. All the analysis I've been describing is now just embedded in the policy engine. Azure policy can also do something really cool. When we started doing this R&D, it can actually modify the SKU on the way through. So we can say, you know what, if it's not production, just fix it, make it the optimal. So this kind of gave us in one go all that vision I was talking about. We can warn if it's not technically compatible, if it's too small. We can even fix it on the fly in certain cases if that makes sense, all through the embedded policy engine. So again, we think this is pretty powerful because it takes everything we do and just makes it happen automatically in the stack. And probably the most powerful part is back to what I was talking about with that spend tolerance. Somebody can say, you know what, I want to rein this in. I'm going to bring my spend tolerance down to 1.5x, meaning I'm not letting anybody deploy on an instance if it's more than 50% more expensive than the optimal that we've determined. There's something much cheaper you can run it on. If you do that, again, that just comes down into the policy engine. Now we've got smaller guardrails. The guardrails are kind of pulled in a bit. We're giving a little less freedom, but still freedom. So if somebody goes and tries to deploy something really big, it'll catch that and say, whoa, that's beyond our spend tolerance. So it's a FinOps warning right in the stack. And again, I want to stress that. Right in the deploy stack, you can give a very, very intelligent FinOps warning saying, there is something that's about 2/3 the cost of that or less that you could be on. So I'm going to warn you, could block you. This automatically goes right into the compliance console for the cloud provider, in this case, Azure Compliance Console, and right back to the team. So it actually, again, gives it an almost native policy enforcement through the stack, through the policy engine and the consoles. And it's really two big elements of this. One is just the visual and the policy of being able to set a spend tolerance. And then the other is the ability to embed it in the stack. So we're not saying just do this one thing. Engineers, you do what you like, but if you get too far off the beaten path, we're going to warn you. Instead of making an engineer do something they don't want to do, or maybe they want to do, but they don't have time to do, let's just take a different approach and prevent them from doing something they shouldn't do. And it's almost like a virus scanner. Like if you said to me, hey, Andrew, go and remove these 15 files off your laptop, they look suspicious. That's a pain for me, but I'll agree to install a virus scanner and just not let them get there in the first place. Do I love virus scanners? I don't know, but I agree they're a good idea, so I'll agree to put it on my system. It's the very same thing here. If you jointly agree to put that in the stack, then you get a much smoother operation. One of our customers called this freedom in a box, where I'm letting the engineers do what they want, as long as it's within the pre-agreed guardrails that we all agreed on. And from a FinOps perspective, that powerful policy, it's not just an arbitrary limit. It's not don't spend more than $1,000. It's all doing deep technical analysis to say there is technically a better option that is viable, and everything's relative to that. So we're not saying don't deploy, we're just saying deploy on the most efficient thing possible, as opposed to having some arbitrary spend limit that's going to stop you from deploying. That doesn't make much sense. And again, the guardrails are agreed upon with the engineers. The warnings come from the stack itself. It's authoritative. I'm not chasing you with a report. It actually came out of Azure or Microsoft, Amazon, as the case is. And it doesn't matter how it's being deployed, it's going to catch it. We're pretty excited about this. We think it's a new paradigm. Visual itself alone is pretty cool because it's a great way just to see the cloud providers' products, what they're selling you, and what you should be using. All right, so just to wrap it up, if you're interested, there is a great report on this space. We like it because we're considered a leader in it. And that's not including what I just showed. So hopefully that'll move us even further into the center if you're interested in that gig ohm. For qualified organizations, Intel does offer what they call Intel Cloud Optimizer. It's based on Densify, and they will fund it. They will sponsor it for a year. You can check that out. And if you qualify, again, it's a great way to go because all the great functionality based on our analytics from Intel.
Feel free to scan the QR codes for access as we go along. We do have a poster available for download. The poster covers the visualization of the 12 risks associated with Kubernetes resource management. And as well, pretty exciting, we've recently launched a podcast, and it is also hosted by Andrew, and it focuses on interviews with IT and technical leaders. Each episode dives into conversations about their careers, as well as insights into the latest cloud trends and best practices. We have episodes with leaders from Liberty Mutual, Intel, and our latest one will be out with Verisk, which is going out on December 19th. Lastly, if you're interested in learning more about Densify, just keeping up with the latest news, do feel free to follow us on social. And with that, I thank you everyone for joining us today, and we hope to see you at the next webinar. Thank you, Andrew, and have a great rest of your day.
Yeah, thanks everyone.